Now we are ready to put everything together to finally build a full model of the competitive market, which is going to tell us what are the allocations that are produced when consumers freely trade in a market. This model has three key assumptions. Assumption one says that every consumer is a price taker. And I'm going to capitalize that because it's a very important notion. And I will come back to the explanation in a second. The other assumption is that every firm is also a price taker. What do we mean by that? What we mean by that is that when firms, for example, are deciding how much to sell, they look at the prices, at the distribution of prices that other firms are offering, and they don't believe that they can affect the price. Therefore, they assume that the price in the market at which they can sell things is fixed, is taken as given. Similarly, every consumer, when they are deciding how much to buy, take the distribution of prices in the market as given. They don't believe that through their actions of buying more or less, they can affect that price in the market. The third assumption of the model is that market forces rapidly drive prices to a market clearing level, clearing level at which the aggregate demand at that price is equal to the aggregate supply at that price. It's called market clearing because aggregate supply is equal to aggregate demand. The price-taking hypothesis is justified as long as the number of consumers and the number of firms is large. Why is that the case? Well, if there are many consumers and many firms, and each one of them is a small part of the market, a small share of the market, then none of them have market power in the following sense. If one of them decided, well, I'm not going to trade as long as you don't trade at this price that is my ideal, it's such a small fraction of the market that the entire market could settle in exactly the same place approximately without taking that person into account. So every person, every actor is approximately negligible with respect to the entire market. So implies it has no market power to influence prices. Now, in Unit 6 and 7, we're going to study what happens when the number of firms is small and this assumption does not hold. But one thing that we're going to learn there that is reassuring is that this market price-taking hypothesis is approximately good even for relatively small numbers of firms. As soon as the firms gets in the dozens, this is not a bad approximation. Now, our model of the competitive market, if taken literally, let me emphasize, if taken literally, relies on an idealization that somehow there is a sign with the market price posted at any point in time, and that every firm and every consumer looks at it and maximizes with respect to it. And somehow this price adjusts ups and down until it reaches this market clearing level. Now, if taken literally, the theory of price formation for that price goes as follows, and it's called the market clearing hypothesis or theory, which is that if P is greater than this market clearing level P star, then there is what is called excess supply. That means that XS at P is greater than XD at P, and that puts downward pressures on prices. Prices at that point decrease. And you can think about, I'll draw it for you in a second. And similarly, if P is less than P star, then there is excess demand, which means that XS of P is less than XD of P, and that put upward pressure on prices. So if you think about the diagram, you have aggregate demand, something like this. You have aggregate supply, let's say something like this. P star is the price at which they cross. That's the market clearing price. That is the market clearing quantity. And the idea is this. If you are in this regime with P greater than P star, there is excess supply because at such a price, there are these extra units that producers want to sell that they cannot sell because at that price, consumers only want to buy that. What happens? The producers say, well, because we want to sell extra units, we are willing to lower the price. Similarly, if you are at a point like this, in a regime where the prices are less than P star, now consumers want to buy more than producers want to sell. There is excess demand. And then the consumers look at this, they cannot buy the units that they want, and they start making offers to buy at a higher price. They push this posted price up. That is literally the dynamic theory that leads you to the equilibrium supporting the market clearing hypothesis. But notice that this theory, if taken literally, is about this posted price that doesn't exist. So how do we interpret this in reality, where you walk around and you can buy the same product at different stores and every store sets its own price? Literally, what you should think is about this game that we are not modeling the details of, in which every firm can post its own price and every consumer can go in and haggle. And the idea is that if there is excess supply, there are firms that are not being able to sell their goods because not enough consumers want to buy at that price, so they start lowering their prices, and vice versa when there is excess demand. And you can think of this price P as a summary of all of the prices in all of the stores, in all of the bargaining relationships that are taking place. The idea is that if we were to model this whole extremely complicated dynamical system, it will converge to a solution in which every trade takes place at the same amount at this price P. Having said this, let me emphasize one key thing, which is, in my personal view, and I'm talking as a researcher, not as much as your faculty as your instructor, one of the biggest and most important unsolved questions in economics is modeling the details of this price formation process. We don't really know what it looks like in detail, and I believe that the person who cracked this problem is going to get a Nobel Prize, and is going to be able to give us insight into a lot of questions. Now, especially to all of the physicists in the class, before you drop your day job and start working on that, let me assure you that that question has been
before we specify in detail
what a competitive equilibrium looks like, we need to take care of a small detail that is sometimes not important, we can ignore, but for some questions and some applications down the line that we want to get insight on is important. The problem is that some of the firms are going to make profits, and those profits have to be returned to consumers, and they end up as consumption of good M. So we need to keep track of that. And in particular, we're going to denote by sigma of person I of firm F. So this is the person, the consumer, and this is the firm. And this is a number between 0 and 1. What is the fraction of firm F owned by the consumer, by consumer I? And let me denote by pi I of P what are the profits of firm, pi F of firm F at price P. We know how to compute those from unit 3. Then I'm finally going to denote by pi of I of P the sum over all of the firms of sigma IF pi F of P. And if you think of what this is these are all of the shares that consumer I owns in the different firms multiplied by the profits. So this is the total profit income for consumer I. So why is this important? Because in equilibrium, we're going to have that MI star, sorry, let me use the same notation, I apologize, that I used before. MCI star, which is the amount consumed by consumer I of good M in equilibrium, is going to be its wealth minus the equilibrium price times the quantity that he buys of the good X plus the total profit income that the consumer gets at the equilibrium price. Notice that all of it ends up consumed in good M, and it doesn't really affect the consumption of good X given the quasi-linearity assumption. Now we're ready to provide a formal definition of a competitive market equilibrium, which is going to be a price P star at which the aggregate supply at that price is equal to the aggregate demand at that price. That's it. A competitive market equilibrium is going to require finding such a price and the allocation, let me call it alpha star, that it induces. Okay, so what is the allocation alpha star that it induces? Let's talk about it. For the consumer, for each consumer I, we have that it's going to consume an amount X di, which is going to be equal to the amount that it demands at price P star, that is of good X, and of good M is going to consume, sorry, this is a C in the notation of allocations that I gave you, is going to consume its wealth minus P star XID P star plus whatever profit income he has at P star. What about for the firms? Let's say for every firm J, we're going to have that the amount that is supplied by firm J is just going to be its supply at that price, and that its usage of inputs of production in the form of this M good is going to be equal to the cost of firm J of producing that good. The amount that it wants to sell.